Alright, so let's talk about the hypothesis test and R-squared in simple regression. In the previous lesson, we examined sales price and mileage data to collect data collected at ABC. We fit a regression line to describe the relationship between mileage and sales price, and then perform the hypothesis test to determine the line's significance. What assumptions did we make about our data, and how can we verify them? Regression has the following three assumptions. Errors are random and independent. Errors are normally distributed, and errors have constant variance across all values of x. So we'll discuss each one of these in detail. To check the assumptions, we evaluate the errors in our regression model by examining the residuals. Recall that the residuals represent the difference between the observed and fitted values. The easiest way to evaluate the residuals is by using residual plots. The first assumption states that errors are random and independent. To ensure that the sample data are random, collect data using random selection techniques. It's possible that data may not be random, but good sampling techniques will ensure they behave as if they are random. This will minimize the chance of selecting a sample that is not representative of the population. The independence assumption specifies that the errors are not affected by the order of data collected. To check this assumption, we can plot the residuals in the order that the data were collected and look for any patterns. Here is the plot of the residuals versus the order of the data. The order is determined by how data are entered into the worksheet. The first observation on the graph corresponds to row 1 in the worksheet. For this plot to be useful, so we need to enter data in the statistical software in the same order they were collected. If data were not collected in any meaningful order, or if the data were taken is unknown, so do not use this plot. Here are two residual versus order plots. The points on these plots fall in a random order and do not exist any patterns. The residuals appear to be independent and independent of one another. These two plots, however, display detectable patterns. This plot indicates that the residuals may not be independent. The points are gradually decreasing over time, and this plot also exhibits a problem. There seems to be an abrupt shift in the residual values. If we detect patterns in the residuals versus order plot, we should determine the cause. Possible causes are the omission of unimportant variable or problems during data collection. Here is the plot for residuals versus order from the ABC example. So do the points appear to be randomly distributed and independent? We see the residuals appear to be randomly distributed and no unusual patterns exist. We can assume that the errors are random and independent. Notice that there is one residual that appears to be an outlier and should be investigated. The second assumption states that the errors follow a normal distribution. To test this assumption, we can use a normal probability plot. If the residuals follow a straight normal distribution, they should approximately follow the straight line on the plot. Here are two normal probability plots. They describe the residuals that likely follow a normal distribution. We can see that these residuals approximate a straight line. And these two plots exhibit patterns that indicate that the residuals do not follow a normal distribution. Here is the normal probability plot of the residuals for the ABC example. So do the points appear to follow a normal distribution? We see the residuals approximately follow a straight line, which means the residuals follow a normal distribution. Notice that there is one residual that appears to be an outlier and should be investigated. The third assumption states that the variance or spread in the errors across the values of x is constant. To test this assumption, we can plot the residuals versus order versus the fixed values. Notice that the residual values are on the vertical axis and the fitted values are on the horizontal axis. Remember that the fitted values are obtained using the regression equation. These plots demonstrate constant variance across the x values. The scatter of the points around the line is similar across all values of x, and no unusual patterns in the data are present. This plot demonstrates a common problem. The residuals increase systematically with the fitted values, which is sometimes called the funnel or megaphone effect. Here is a plot of the residuals versus the fitted values for the sales price and mileage data. So can we assume that the errors have constant variance across all values of x? The residuals are scattered in a constant manner for all values of x, indicate the variance is constant across all values of x. Notice that the point in the upper right corner here is the same outlier that appears in the other residual plots. For the IBC example, the residual plots indicate that all the three assumptions for the regression are met. The errors are random and independent. The errors are normally distributed, and the errors have constant variance across all values of x. So therefore, IBC can use the results to make projections about the sales price of the sport cars that come off of 3-year leases. So let's review. Verify all assumptions about the errors using residual plots to confirm that the regression analysis is valid. The assumptions for the regression are that errors are random and independent, errors are normally distributed, and variance in the errors across all values of x is constant. Examine residual plots to check regression assumptions. you for your listening. In the next lesson, we'll talk about the measurement and systems analysis.